Podcast Part 1, Extended Version Introduction and Background to Resveratrol Research. Welcome to this first episode. Today we're opening the microphone to delve into the fascinating world of resveratrol, a natural compound whose therapeutic potential has captivated scientists and health enthusiasts alike. We'll base our conversation on the comprehensive review conducted in 2024 by Faisal et al., published in Food Science and Nutrition, where the scientific evidence to date has been compiled and analyzed. Our goal is to offer you a general audience the most relevant, clear, and practical information about what resveratrol is, where it comes from, how it works in our bodies, and why it's becoming one of the star molecules in nutrition research. To begin, let's precisely define this polyphenol. Resveratrol is a phytoalexin, a substance that plants naturally synthesize as a defense mechanism against external aggressions, such as fungal attacks, ultraviolet radiation, or wounds. It is found in especially high concentrations in the skin of red grapes, historically linking it to the theory that moderate consumption of red wine could protect the heart, French paradigm. It also appears in berries such as blackberries and blueberries, in peanuts, and in other plant sources. This diversity of origins speaks to its ecological importance and its versatility as a nutrient. And how did it reach us? Resveratrol was isolated in 1939 by the Japanese chemist Michio Takaoka, but it only achieved scientific celebrity status in the 1990s, when its purported cardioprotective effects became known. Since then, thousands of studies have accumulated, from test tube cells to animal and human trials, exploring its multiple biological actions. Now, let's delve into its chemical characteristics. Resveratrol is composed of two phenolic rings joined by an ethylene double bond, with three hydroxyl groups, O, that give it its antioxidant capacity. There are two isomers, trans resveratrol and cis resveratrol, the former being the most stable and of greatest therapeutic interest. However, light, heat, and pH variations can convert the trans form to cis, reducing its effectiveness. This detail directly interferes with its stability, a major challenge for the supplement industry and for the consumer who wants to take advantage of its benefits without losing potency. Let's talk about bioavailability, a term that describes how much of that absorbed molecule reaches our bloodstream in an active state. Although in vitro studies show up to 75% intestinal absorption, subsequent measurements reveal that less than 1% of ingested resveratrol is detected in plasma as a free molecule. Most of it is rapidly conjugated to glucuronides and sulfates in the gut and liver, so the actual concentration that circulates and reaches tissues is very low. This hepatic first-pass effect drastically limits its practical efficacy and explains why clinical trials sometimes fail to achieve the results promised by basic studies. To overcome this obstacle, research has shifted toward nanotechnology and advanced delivery systems. Liposomes, small phospholipid capsules, and polymeric nanoparticles are emerging as ideal vehicles to protect resveratrol from degradation, improve its solubility in aqueous media, and extend its presence in the bloodstream. Furthermore, microencapsulated emulsions have been developed that release the compound in a sustained manner, which could translate into greater efficacy at lower doses. These advances open the door to next-generation supplements, where the raw material is the same, but the formulation makes the difference. With this pharmacokinetic and technological basis understood, let's move on to the objectives of the review. 1. Evaluate the real scope of the antioxidant and anti-inflammatory effects of resveratrol. 2. Synthesize the evidence on its cardioprotective, neuroprotective, immunomodulatory and antidiabetic actions. 3. Present the findings on bone health and intestinal health. 4. Analyze its possible risks, low bioavailability, instability, lack of very long-term studies. And 5. Propose a SWOT analysis, strengths, weaknesses, opportunities, and threats, that allows professionals and consumers to place resveratrol in a practical context. In the following episodes, we'll unpack each of these points. We'll study clinical examples of older adults who improved their bone density, lipid profiles of overweight patients, cases of neuroprotection in stroke models, and the implications of its intake for the regulation of gut microbiota. We'll also address reported adverse effects, such as gastrointestinal discomfort, potential interactions with anticoagulant medications, and the lack of conclusive safety data after years of continuous consumption. To close this first segment, I leave you with this reflection: behind resveratrol's fascinating potential lies a major dosage challenge. While dosages of 100-500 mg daily are common in the laboratory, many supplements on the market don't even reach 50 mg per dose. And if we add its rapid metabolism, it becomes clear that more is not always better, and that the quality of the formulation, nanovehicle, adjuvants, timing of intake, can be just as important as the quantity in milligrams. Thank you for your attention. In Part 2, we'll delve deeper into its powerful role as an antioxidant and inflammation modulator, breaking down key studies and explaining how these actions can translate into concrete benefits for our daily lives. See you next time. Podcast Part 2, Extended and Duplicated Version Antioxidant and Anti-Inflammatory Properties of Resveratrol. Welcome back to our second episode. Today we'll delve into two of the most studied and significant effects of resveratrol, its antioxidant capacity and its anti-inflammatory action. Understanding these mechanisms is essential to assessing how this natural compound, present in the skin of red grapes and other plants, can tangibly impact our daily health. To begin, let's remember that free radicals are unstable molecules that the body generates naturally, for example, during energy metabolism or through external factors, sun exposure, environmental pollution, tobacco smoke, and psychological stress. If not neutralized, these radicals can damage our lipids, proteins, and DNA, leading to the so-called oxidative stress, a process implicated in cellular aging and the development of chronic diseases such as atherosclerosis, diabetes, Alzheimer's, and various types of cancer. Resveratrol, thanks to its 3O-hydroxyl groups in its phenolic structure, acts as a radical scavenger. By donating electrons or hydrogen atoms, it stabilizes reactive species such as the superoxide radical, O, and the hydroxyl radical, O, interrupting the chain reactions that would otherwise generate further oxidative stress. In laboratory studies, concentrations as low as 5 to 10 micromoles per liter, m, of resveratrol have been shown to inhibit lipid peroxidation in cell membranes by 50%, which is a surprising result considering the compound's low bioavailability. In animal models of accelerated aging, administration of 10 mg/kg of resveratrol for 6 months reduced malondialdehyde, MDA, levels, a biomarker of oxidative damage, by 30%. These findings suggest that, in mice, resveratrol strengthens endogenous antioxidant systems. Despite interspecies differences, some human clinical trials have shown promising results. For example, healthy volunteers who ingested 150 mg of resveratrol daily for 4 weeks experienced a 20% increase in the activity of key enzymes, superoxide dismutase, SOD, and glutathione peroxidase, GPX. In addition, a significant reduction in LDL lipoprotein oxidation rates was observed, which could translate into a lower cardiovascular risk. But the power of resveratrol doesn't end with radical neutralization. This polyphenol exerts a potent anti-inflammatory action, modulating signaling pathways that regulate the cellular response to damage. In chronic low-grade inflammation present in obesity, insulin resistance, and cardiovascular disease, the NF-kappa B and MAPK pathways remain hyperactive, generating pro-inflammatory cytokines such as TNF-alpha, IL-6, and IL-1 beta. Resveratrol intervenes by inhibiting the degradation of the inhibitor IB-alpha, preventing the NF-kappa B factor, P65 subunit, from entering the cell nucleus and activating the pro-inflammatory gene machinery. It also reduces the phosphorylation of the P38 MAPK and JNK kinases, slowing the signaling cascade that leads to the production of inflammatory molecules. A clinical study in patients with metabolic syndrome demonstrated that 300 mg of resveratrol daily for 8 weeks led to 15% to 25% decreases in plasma levels of TNF-alpha and IL-6, in addition to a slight improvement in insulin sensitivity. This not only corroborates its anti-inflammatory potential but also suggests a beneficial effect on metabolic parameters. In parallel, research in animal models of ulcerative colitis has confirmed that resveratrol administration reduces inflammatory cell infiltration in the intestinal mucosa and decreases the expression of COX-2, cyclooxygenase 2, which is associated with pain and acute inflammation. The combination of antioxidant and anti-inflammatory activity makes resveratrol an attractive candidate for chronic disease prevention. By protecting our blood vessels from oxidative damage and modulating the production of inflammatory molecules, it may slow the formation of atherosclerotic plaques, reduce arterial stiffness, and improve endothelial function. In fact, some studies have measured flow-mediated vasodilation in brachial arteries, a proxy for vascular health, and found that 200 mg of resveratrol increases this vasodilation by 25% after 4 weeks, a key benefit for minimizing hypertension and the risk of heart attack. However, it's worth reiterating a key point: resveratrol's low bioavailability limits the magnitude of these benefits in clinical practice. Most successful trials use daily doses of 150 to 500 mg, much higher than what we consume with a glass of red wine, which provides just 1-2 mg. Furthermore, the sulfate and glucuronide conjugates formed in the intestine and liver have limited biological activity. To address this challenge, nanotechnology has emerged with innovative solutions: nanoemulsions, liposomes, and polymer nanoparticles that protect resveratrol from the acidic environment, make it more soluble in water, and prolong its release into the blood. With these technologies, the plasma concentration of free resveratrol after the same dose can be multiplied by 3 or even 5 times, increasing its antioxidant and anti-inflammatory efficacy. Finally, let's talk about safety. Resveratrol is generally considered well tolerated across the dose ranges studied. However, some people may experience gastrointestinal discomfort, nausea, diarrhea, especially when doses exceed 1000 mg per day. Caution is also advised for those taking anticoagulant drugs, such as warfarin, or anti-platelet agents, as resveratrol has a slight inhibitory effect on platelet aggregation. While the risks are low, it's wise to consult your doctor before starting long-term supplementation, especially if you have a history of peptic ulcer disease or clotting disorders. In short, resveratrol offers a dual impact: It combats oxidative stress by neutralizing free radicals and attenuates chronic inflammation by modulating key cell signaling pathways. These properties make it a potential ally against aging, atherosclerosis, and various inflammatory diseases. However, its limited bioavailability requires the use of advanced formulations in appropriate doses, and its safety, while favorable, must be evaluated in contexts of comorbidities and polypharmacy. In the next episode, we'll discuss the cardioprotective and neuroprotective effects of resveratrol, analyze specific studies in models of stroke and cardiac dysfunction, and begin to review the risks of extrapolating data from high-dose studies to daily supplementation. Don't miss it. Podcast Part 3, Extended Version Cardioprotective and Neuroprotective Effects of Resveratrol. Welcome back to our third episode. Today, we'll take a deep dive into two crucial aspects of resveratrol's benefits, its ability to protect the cardiovascular system and its ability to safeguard brain function, exploring the most relevant scientific evidence and how it translates to everyday health. To start, let's focus on the heart and blood vessels. Resveratrol has been shown to positively modulate the function of the vascular endothelium, which is the layer of cells that lines the inside of our arteries. The endothelium regulates vascular contraction and dilation by releasing nitric oxide, NO, an essential gas that relaxes vascular smooth muscle. In a controlled clinical trial, individuals with mild hypertension who ingested 150 mg of resveratrol per day for 4 weeks showed an average reduction of 5 mm Hg in systolic blood pressure and 3 mm Hg in diastolic blood pressure, compared to placebo. This decrease, although modest, is comparable to that achieved with dietary changes such as the DASH diet, and adds an additional benefit when accompanied by exercise and reducing salt intake. In addition to improving blood pressure, resveratrol inhibits the oxidation of LDL, the bad cholesterol that, when oxidized, adheres to the endothelium and triggers the formation of atherosclerotic plaques. Studies in animals fed high-fat diets showed that resveratrol supplementation reduces macrophage infiltration in the arterial wall, reduces the thickness of the aortic intima by 20%, and down-modulates the expression of adhesion molecules, VCAM1, ICAM1, that recruit inflammatory cells. These effects translate into a cleaner vascular barrier that is less prone to blood clot formation. Furthermore, resveratrol exerts an antithrombotic effect by inhibiting platelet aggregation. In a study in volunteers with moderate cardiovascular risk, 100 mg of resveratrol daily for 2 weeks reduced ADP-induced platelet aggregation by 15%, an effect similar to that of low-dose aspirin but with a lower risk of gastrointestinal bleeding. Thus, resveratrol offers a dual profile. It promotes blood flow and protects vascular integrity without the classic side effects of conventional anti-platelet agents. Let's now turn to the nervous system, where protecting brain tissue is critical for preventing cognitive decline and neurodegenerative diseases. Resveratrol, unlike many polyphenolic compounds, crosses the blood-brain barrier, allowing it to act directly on neuronal tissue. In rat models of cerebral ischemia, a simulation of stroke treatment with resveratrol before and after the event reduced infarct volume by 30–40%. The underlying mechanisms include inhibiting excitotoxicity by regulating glutamate levels, reducing free radical production in neurons, and preserving the blood-brain barrier, preventing edema and the entry of inflammatory mediators from the bloodstream. At the molecular level, resveratrol activates the SIRT1/PGC1 alpha pathway. SIRT1, a NAD-dependent sirtuin, promotes mitochondrial biogenesis and DNA repair, strengthening neurons' resistance to metabolic stress. PGC1 alpha, meanwhile, is a coactivator that regulates genes involved in mitochondrial function and energy metabolism. The joint activation of SIRT1 and PGC1 alpha improves mitochondrial health, which is crucial for maintaining neuronal energy and delaying apoptosis processes induced by oxidative damage. In humans, the evidence is beginning to gain strength. A study of 60 healthy adults aged 60–75 years who received 200 mg of resveratrol daily for 26 weeks observed a 10% increase in cerebral blood perfusion in regions critical for memory and attention, as measured by functional magnetic resonance imaging. Furthermore, participants showed modest improvements in tests of verbal memory and concentration, suggesting that resveratrol could be an adjuvant in programs to prevent age-related mild cognitive impairment. Another interesting benefit is resveratrol's potential impact on the glymphatic system, the brain's cleanup mechanism primarily active during sleep. Proper cerebrospinal fluid flow and waste removal, such as amyloid beta protein, depend on adequate perivascular vessel dilation. By improving NO production and reducing perivascular inflammation, resveratrol may increase the efficiency of this system, contributing to better sleep quality and preventing neurodegenerative diseases. However, it's essential to emphasize the limitations. Much of the research uses high doses, often exceeding 300 mg daily, and formulations containing nanoparticles or liposomes to enhance absorption. In practice, commercial supplements typically offer 100 mg per capsule, with reduced bioavailability. Therefore, although the therapeutic potential is promising, clinical results at low doses and with traditional formulations do not always replicate laboratory findings. Consequently, synergistic strategies are being explored, combining resveratrol with other antioxidants such as quercetin or curcumin to enhance its effect at lower doses, or CO administering it with NAD precursors, NMN, NR, to enhance sirtuin activation and optimize mitochondrial function. These combinations could reduce the required dose of resveratrol, decreasing costs and potentially inducing digestive discomfort associated with high intakes. To conclude this extended episode, let us remember that resveratrol improves endothelial function, reducing blood pressure and protecting against atherosclerosis. It has antithrombotic activity, similar to aspirin, but with a lower risk of bleeding. In the brain, it promotes neuronal survival after ischemic events, improves perfusion, and could optimize glymphatic cleaning. SIRT1/PGC1 alpha activation strengthens mitochondrial health, key to healthy aging. Low bioavailability and the need for high doses are challenges that can be overcome through advanced formulations and synergies with other compounds. In the next and final episode, we'll address the potential risks of resveratrol and conclude with a comprehensive SWOT analysis, summarizing its strengths, weaknesses, opportunities, and threats in a real-world context. Don't miss Part 4. Podcast Part 4, 3x Extended Version Risks, SWOT Analysis, and Recommendations for Resveratrol Use. Welcome back to the conclusion of this series dedicated to resveratrol. In this final installment, we'll delve deeper into the risks, conduct a thorough SWOT analysis, and conclude with practical recommendations to help you integrate this compound into your daily life safely and effectively. Detailed risks and limitations. Although resveratrol is generally well tolerated, it is not without potential drawbacks. Let's start with its low bioavailability. Although up to 75% of the oral dose can be absorbed in the intestine, less than 1% reaches the systemic circulation as free resveratrol before being converted into sulfates and glucuronides. These conjugates often have limited biological activity, necessitating the use of high doses, 150-500 mg daily, or advanced formulations, liposomes, nanoemulsions, micellar powders, that protect the molecule and prolong its release. The price of these products is usually significantly higher, limiting their accessibility to the average consumer. Second, let's talk about gastrointestinal discomfort. In clinical studies where participants ingested more than 1,000 mg per day for weeks, cases of nausea, diarrhea, abdominal pain, and a feeling of stomach fullness were reported. These adverse effects, while they usually subside when the dose is reduced or divided into several doses, are a reminder that any supplement, no matter how natural, can disrupt digestive balance and intestinal flora if overused. Another critical point is its interaction with drugs. Resveratrol inhibits hepatic cytochrome P450 enzymes, especially CYP3A4 and CYP2D6, which are responsible for metabolizing a wide range of medications, from statins and antidepressants to anticoagulants. It also has a mild anti-platelet effect, which, when combined with aspirin, warfarin, or clopidogrel, may increase the risk of bleeding. Therefore, in patients on chronic medication regimens cardiological, oncological, or psychiatric, it is essential to consult with a doctor before incorporating resveratrol and, if possible, adjust the dose or monitor coagulation parameters. The lack of very long-term studies is a notable omission in the literature. While there are trials that extend up to 2 years of use, we lack reliable data on potential adverse effects after several years of continuous supplementation. We do not know whether long-term supplementation could affect thyroid function, the hormonal axis, especially in premenopausal women, or calcium homeostasis, given its interactions with growth signals and cell renewal factors. This knowledge gap leads many experts, as a precaution, to suggest rest periods from supplementation, e.g., 3 months on/1 month off, or periodic monitoring of hormonal and metabolic parameters. Finally, there is enormous variability in the quality of supplements available on the market. As it is not a regulated drug as such, resveratrol circulates in forms ranging from full-spectrum powders, with impurities and solvent residues, to 98% purified extracts. Furthermore, the less active cis-isomer resveratrol can predominate if the product is not handled under low light and temperature-controlled conditions. This creates great uncertainty for the consumer. 2 identical bottles can offer very different potencies. Comprehensive SWOT analysis. Strengths. 1. Broad scientific support. Dozens of in vitro, animal, and human studies support its antioxidant and anti-inflammatory properties. 2. Proven cardiovascular benefits. Improved endothelial function, reduced blood pressure, and mild antithrombotic activity, resulting in protection against heart attacks and strokes. 3. Neuroprotection with clear mechanisms. Crossing the blood-brain barrier, activating sirtuins, SIRT1, and promoting mitochondrial biogenesis. 4. Multimodal spectrum. In addition to heart and brain health, it exerts immunomodulatory, antidiabetic, and bone protective effects, making it a versatile nutraceutical. 5. Relative safety at moderate doses. Generally well tolerated up to 500 mg/day with no serious effects in healthy subjects. Opportunities. 1. Emerging nanotechnologies. Liposomes, nanoemulsions, and hydrogels that improve sustained release and absorption, reducing the required dose. 2. Synergies with other compounds. Combinations with quercetin, curcumin, or NAD precursors, NMN, NR, to enhance their antioxidant and epigenetic action. 3. Personalized nutrition. Adapt doses based on genetic polymorphisms, SIRT1 variants or metabolizing enzymes, and each individual's metabolic profile. 4. Clinical applications. Trials targeting specific populations, cancer patients, protection of healthy organs during chemotherapy, geriatric patients, prevention of sarcopenia, and metabolic patients, improvement of insulin resistance. 5. Growing consumer interest. Greater awareness of natural supplements opens the market for high-quality, certified products. Weaknesses. 1. Very low bioavailability. Less than 1% reaches the circulation as free resveratrol, limiting clinical effects. 2. Need for high doses or expensive formulations. This raises the final price and restricts mass availability. 3. Heterogeneity of studies. Variations in dosage, duration, population, and supplement quality make it difficult to draw unanimous conclusions. 4. Lack of strict regulation. Uncontrolled markets allow adulterated products or products with inconsistent potency. 5. Lack of very long-term data. We are unaware of possible adverse effects after 5 or 10 years of use. Threats. 1. Drug interactions. Increased risk of bleeding or hypoglycemia when combined with anticoagulants or antidiabetics. 2. Excessive marketing and sensationalism. Exaggerated headlines, cure for aging, can generate skepticism and distrust of science. 3. Adulteration and contamination. Possible presence of pesticides, residual solvents, or inactive cis isomer, which undermines the supplement's credibility. 4. Competition from other nutraceuticals. Polyphenols such as curcumin, EGCG, and astaxanthin are also competing for the anti-aging market. 5. Displacement by specific drugs. As more potent and targeted synthetic molecules are developed, resveratrol could be relegated to a complementary role. Practical recommendations and usage strategy. For those who wish to experiment with resveratrol safely and effectively, I suggest these steps. 1. Prior medical consultation. Before starting, especially if you are taking chronic medication, anticoagulants, antidiabetics, antidepressants, or if you have liver, kidney or thyroid disease, request a general checkup and advice on possible interactions. 2. Choosing a quality product. Prefer supplements with certifications, NSF, Informed Sport, USP, that guarantee purity and concentration. Trans resveratrol is clearly specified and that the absence of excess cis isomer is guaranteed. Opt for advanced formulations, liposomes, nanoemulsions, if you are looking to maximize absorption. 3. Progressive dosage. Start with 50-100 mg daily, preferably in 2 doses, morning and evening, to maintain constant levels. After 2-4 weeks without adverse effects, they can be escalated to 300-500 mg daily, according to individual goals and tolerance. 4. Monitoring and strategic breaks. Perform liver function, ALT, AST, kidney function, creatinine, BUN, and coagulation profile, PT, PTT, checks every 3-6 months. Implement rest periods, e.g., 3 months on and 1 month off, to avoid enzyme saturation and possible desensitization. 5. Smart combination. Associate with quercetin, 50-100 mg, to improve bioavailability and enhance antioxidant action. Include NAD precursors, NMN, nicotinamide riboside, to strengthen the SIRT1 pathway and mitochondrial health. Maintain a diet rich in natural polyphenols, red fruits, green tea, pure cocoa, and fiber to support the microbiota. 6. Complementary lifestyle. Do not neglect the consumption of fruits, vegetables, and healthy fats, omega-3, that add anti-inflammatory effects. Practice regular exercise, both aerobic and strength training, to take full advantage of the improvement in endothelial and muscle function. Prioritize quality sleep, essential for the function of the glymphatic system and cellular repair. 7. Continuing education. Stay informed through academic sources, PubMed, Science Direct, and avoid sensational headlines. Critically evaluate the evidence, distinguish between preclinical data, cells, animals, and human clinical trials. With this expanded risk analysis, the complete SWOT analysis, and these practical recommendations, we conclude our journey through the world of resveratrol. We hope this information serves as a guide for the responsible and beneficial use of this compound, always within the framework of a comprehensive health approach. Thank you very much for listening, and until next time.